calculate the surface area of the cuboid above. So first of all, I want to know what a surface area is. So surface area and volume are two different things. So first of all, volume is to calculate how many space there are. For example, I have a lot of tissue papers here. I want to calculate the volume of all of these tissue papers. And the surface area is I want the surface area. So basically, surface area is that you're calculating the surfaces of a shape, a 3D shape. Any 3D shape, it can be a pyramid, a prism, a cube, a cuboid, it can be any 3D shape. As long as you have the surface, and if it asks for the surface area, basically you find the surface area, which is this and this and this. There are other surface area. They just didn't show it. So surface area is something that you have to calculate. It is a area. You have to calculate the area of a surface. For example, let's say I'm doing this square. Let's say I'm going to calculate the surface area of this square. Let's just focus on the square. Now we know what area is. Area is something times something. Now you know a square has same sides, which is 8 and 8. So we do 8 times 8, which is 64. So the area of the square, let's say area of square, I'll just call it SQ, represents square. Area of one square. We calculated one square of the surface area. Area of, let me write SA, which represents surface area. Surface area of one square is 64, because 8 times 8 is 64. Now, I'm gonna take you to a website called Tinkercad so that you understand easier. So the surface area is that we want to calculate the area here and the area here. We want to calculate the whole surface area of the whole shape. Now we have the shape of the front. We calculated that. Let's say the side, this square, is 8 times 8. The surface area of this square is 64. Now, are there more squares? Yes, because if you take a look at a cuboid, it is a 3D shape. And if you take a look at it, there are two of them. So one is here, this is a square. One is here, the other one is here. So as you can see, this is front, and this is back. And they're exactly the same. So, because we see there are two of them, and we have calculated one square, now I want two square, it will become 64 times 2, which is, let's see, 64 times 2 gives us 128. So that's 2 squares. CMQ, remember to write the square. Now, I've calculated one of the surface area. Now I want to calculate the whole cuboid, not just the squares. So we have finished the square. Now let's take a look at the rectangle here. So as you can see, this is a rectangle. And let's take a look here. There's also another rectangle. So first of all, I want to know one of the rectangle. We're trying to calculate. Just now what we were seeing this rectangle here. So just now we saw this rectangle. We were seeing this rectangle, and I want to calculate the surface area of this rectangle. So again, surface area, I write SA of, let's say, this rectangle, rect, is equal to, now I have the length is 15 and the width is 8. So I calculate the area, which is 15 times 8. And that gives, 15 times 8 gives us 120. Now that's only one of the rectangle. Again, let's go and look at this website. Now what we're seeing here just now, what we saw was this, right? And we saw the rectangle here. Now as you can see, if I flip it over, there's another rectangle on the other side. So there are two rectangles. So again, I want two rectangles, not just one. Then I do 120 times 2. 120 120 times 2 gives us 240. So I'll write it here. So 240 cm cube, because we're calculating surface area, so we must use square, cm square. Now, we finish calculating this here, and this here. Now we're left with, this square. No, this is a rectangle. We're left with this rectangle over here. Now, is this a parallelogram or a rectangle? Be careful not to get confused, because this is actually a rectangle. Because just now, what we were seeing in this picture, we are seeing like this. Am I right? We've calculated the front, the square in front, and the square at the back, and the sides. Now I'm left with the top and the bottom. Now the top, as you can see just now, when we were in this position, we see that, oh, it looks a little like a parallelogram. But if you take a look clearly, it is actually a rectangle. So if it's a rectangle, then that means this is exactly the same, because just now we calculated this rectangle over here. And so that means that this length here is 15 cm, and the width here is 8 cm. So as you can see, they're exactly the same. So if they're exactly the same, then I have another surface area of one rectangle is 120 cm cubed, just the same as before. And then, do we have one only? No, this is the top, and we have the bottom too. Remember, we have a bottom, so there's two. So now I want two rectangle, not just one. So 120 times 2, which gives us 240 cm cubed. So now we have the last step. Do you see that I circled all of these? I want you to add them all together. So 128 plus 240 plus again 240, and that will give us 120 plus 240 plus 240. That gives us 608 cm cubed. That is the total surface area of the cube above.